Yes.
Okay. Well, thanks everybody for bearing with us while we were having some technical issues. I don't think that many people are watching anyway, although there seems to be one person on the Twitch right now, right? This is we're starting to do regular docs clinics now, and just so you know a little bit about our schedule, we're going to be rotating between at this same time every Thursday. We're going to be having a docs working group for the open salt project and related R&D projects like that, like POP and ITEM and Heist. And we are so and then so that will be one week at this time, and then we'll alternate and have our docs working group meeting with these docs clinics. I expressed that really clunkily, but hopefully you get the basic idea. At these docs clinics, we will be happy to just kind of work on docs issues live, and then anybody who comes, if you want help working through your docs issues and getting help and feedback, our team is going to be here to help you. And basically, Derek and I will rotate that schedule. One of us will be available each week that we do that. That being said, next week there is no working group or docs clinic because you should all come to SaltConf and enjoy all the good talks and things there. And in fact, Derek is going to be giving a presentation about the state of the docs. So please come and check that out if you are a friend of the docs and you'd like to learn more about what we're going to be doing in the Open Salt project and beyond. We would love to have you be in attendance, and that is free to register for right now. So feel free to come join us. On that note, what we're going to be doing today, last time that we did a docs clinic, Derek did a really nice walkthrough of how to contribute to the docs in Open Salt. And our goal is to kind of make it easier to onboard with Open Salt. To that end, if you're brand new to Salt, you're attracted to working on an open source project and you've seen that Salt is a popular open source project that you'd like to get involved in, but you aren't sure what skill set or tools you need in order to be able to get up and running. Today, we're going to be talking about a pretty baseline tool that is handy in any open source project that you want to contribute to, and that is Git. So I'm going to share my screen now. Okay, should be a blank screen at this point. All right, so we're going to be talking today about Git for the true beginner. Now, sometimes when I do fancy animations like this, Zoom hangs up, so hopefully we'll be good today. But all right, what are we going to talk about today? We're going to basically talk about 6 things. We're going to talk about what is Git, why is it cool. I'm going to give a very high level overview of how Git works. Then we're going to do some, when I talk about how it works, I'm going to talk about some key terms too. I'm going to talk about how does GitHub and GitLab factor into using Git. And then we're going to talk tools at the end. I'm going to do a demonstration if we have time about how to actually use Git live. So that's what we're doing today. So let's start our fun discussion by talking about what is Git and why is it cool. So I need to give a nerd alert to start out with. I'm going to give a very, very scary, intimidating definition of Git, but it won't be so bad after we break it down. So what is Git? It's a distributed version control system that allows people to contribute asynchronously. All right, that's kind of a mouthful. Let's break that down. Okay, so looking at distributed, that means copies of the project are on many different machines, not just one central machine. For example, let's take Salt. That project is on GitHub, yes, which is our central repository. But if I've made a fork and a clone of that project, it's also on my local machine right here. It's on Derek's machine. It's on Gareth's machine. It's on anybody's machine, potentially. Anybody who's forked and cloned that project has a copy of it. So it can be on lots of different computers at the same time, not just on GitHub. It's also, so Git is also a version control system. That means it'll show you different versions of your file as they changed over time. And We'll talk about what that means, but just kind of keep in mind it basically means it tracks your changes that you've made to your code base over time. And then lastly, it means contributing asynchronously. That means that contributors can come and go and contribute anytime and anywhere. So going back to SALT as an example, people can come and contribute, and then they can add a little bit to the code base, and then they can go off on their merry way and maybe never come back, or they could go off on their merry way and then come back and contribute a little bit more and then leave. And Git is cool with that kind of a scenario. You could be with the project the whole time, you could come and go, not a big deal. So that's what asynchronously means. And it means different people can be contributing at different times, and Git is cool with that. So Git contains basically a snapshot of your complete project at various points in time. This makes it sound a little bit cooler than it probably is, but it's kind of like a time machine for your project. You can go back in time to see the way your project used to look, or you can visit parallel timelines to see what it's looking like on a different person's computer. And in fact, to illustrate why Git is so cool, let's go back in time even more, to the dark ages of software development, in about the time period from the 1950s to the 1980s, before the days of version control. In those days, there was no way to roll code back automatically. Oh, did you push some bad code that broke everything and you need to fix it? Too bad. You just kind of have to remember what you did and roll it back by hand, which sounds really awful. If you wanted to work on the same section of code as somebody else, you either just couldn't, or you'd have to do some heavy planning beforehand. And engineers, they don't love talking to people, so that makes it extra hard. No, just kidding. Engineers like talking to people. It just means a lot of coordination, and that's just difficult to do. It creates a lot of overhead. Plus, what if you liked your old code in the past? Like maybe you had a way that you used to do things, but then things changed, but you want to go back and see how you solved that problem in the past, and you liked it. Well, unfortunately, these are all things that you just couldn't do. So, um, too bad. Then now let's fast forward to the 90s. Let's call it the medieval age of version control. In the 90s, a new tool came about called Subversion, which solved a lot of those problems, but it wasn't perfect. And its main flaw was that it used a central repository to store code. When you have a central repository, that repository becomes a single point of failure. If the repository goes down, nobody can get anything done until it was back up and running again. So that slowed things down quite a bit. Branching was also really difficult. And branching is important because if you want to be able to experiment and mess up on your branch without hurting the central repository, in Subversion, that was really hard to do. Same thing with forking. Forking is really great for creativity too. Let's say you want to take the project and go in a different direction, but I want to keep the good work that's been done so far. That's what forking allows you to do. Again, not really easy to do in the Subversion system. But now we are in the future. We have a solution to all these problems, and that solution is called Git. So yay, it's a distributed version control system that solves a lot of problems. So let's talk about what some of the advantages of version control are. One advantage is that you can store your code. If you lose a copy of your project, that's okay because Git acts as a backup. You can restore your code. If you push some bad code or you liked the old way of doing things better, you can revert to that older version. You can compare code. You can see what changed from one version to another, which is really important for troubleshooting. You can collaborate with each other, which means you can work on the same project at the same time or at different times. You can also review each other's code so that it gets merged in, which ensures that that code is of a high quality. And really something that's really important in open source, you can experiment. You can clone and fork the project, and you can mess up and it won't hurt the main branch, hopefully. But you can do all you want with it and not worry about impacting other people's works. And when I gave this presentation the first time, somebody mentioned that one of the cool things that version control can do is it can allow you to adopt an infrastructure as code model when it comes to configuration management and setting up IT environments or networks or things like that. And that's something that Salt can do really well. So this kind of system is really compatible with an infrastructure as code system. I can't speak to infrastructure as code. I'm not an expert on that yet, but that's the basic idea behind it. Okay, so I am now going to give like a high level overview about how Git works, but we're also going to talk about some key vocabulary terms because Git does have a few buzzwords that are unique to it as a system that take a little while to get used to. So let's say we have a cookbook project where everyone uses Git to contribute recipes to a collaborative cookbook. It's our open source cookbook project. Let's say we've got Frida, who maybe started the cookbook and set everything up for the project. And we've got Ken, who is a cake enthusiast, loves to develop recipes about cake specifically, and is contributing to the project for that purpose. And then we've also got Annie, who is a frosting aficionado and wants to contribute her frosting recipes to the project. And just as a quick side note, you really could do a cookbook in Git. Git can track text files. It's not so great at tracking like Word documents, but it can do plain text pretty well. So keep in mind that this is conceivable. You could actually do this kind of a project on Git. So everybody comes together and wants to create an awesome cookbook. Also, I should also mention, if we were going to take this analogy just a little bit further, you could pretend that Ken is like a back-end developer and is doing the back-end work for the project. And Annie is the front-end developer who's doing the front-end side of the project. So all of these people can come together and create a really awesome project working together. So let's talk a little bit about Frida to start out with. So Frida is the project owner. She manages the repository permissions on GitLab or GitHub. And so she has set up the repository. A repository is a folder that contains all the project's files and version history. A lot of times you'll hear people call it a repo for short. So you'll hear the term repo a little bit more commonly. So imagine that with our cookbook folder, we've got basically a couple of different files. We've got a carrot cake recipe, a red velvet cake recipe, and a yellow butter cake recipe. So we've got all of those things in our awesome cookbook. And that is what the repository is. It's a collection of those files, essentially. Now let's talk about Ken, who wants to contribute those cake recipes on a working copy of the repository on his computer. In order for Ken to be able to contribute to the project, he's going to need to make what's called a clone. That's a full copy of the repository on the contributor's local computer, meaning all the files in that project get copied over to Ken's computer. So in order to do that, he's going to take the awesome open cookbook, which is the original project, and then he's going to create a fork or a clone of that project. And that's essentially a little copy of the cookbook on his own machine. So that's what he does. Oh, and on that note, so a couple of terms to just be aware of are the terms upstream repo and downstream repo. So again, the original awesome open cookbook is the upstream repo. That's the central repository that has all of the project contributors pushing and pulling their changes to that repo. Then Ken's copy is the downstream repo. That's his clone where he makes his changes to the project that he'll eventually push upstream to the open cookbook. Now, all right. Okay, so let's look at a specific example of how this would work. So one of the key terms that you need to understand when it comes to Git is the concept of a branch. That's an independent copy of the files that you can make your changes on. Let's go back to Ken and the example of him. Let's say Ken's decided he wants to make some changes to the cookbook. Like he in particular, he wants to tweak and fine tune that red velvet cake recipe and improve it in some way. So what he's going to do is he's going to create a new branch and he's going to call it Red Velvet 2.0, shall we say. And then he's going to get to work. He's going to go off into his test kitchen and test out all the ways that he can improve this recipe. Let's say that in his test kitchen, he determines that he it's the recipe is better if you have 3 eggs instead of 2. So what he's going to do is he's going to change the recipe and then he's going to commit it. And as it says here, committing is where you just basically save your changes to a branch. So he updated it from 3 eggs to 2 and committed that into the repo. Then he's going to go back to work a little bit. Let's say he discovers that the recipe is better if you soften the cream cheese first. So, okay, he puts that into the instructions and updates it, makes another commit. And then he says, okay, I find that this is better if we add a teaspoon of baking soda. And so he makes that change and commits it. At this point, he's decided, all right, this recipe is really good at this point. Time to merge it into the main branch. So that's exactly what he does. He starts to merge it in. And so in order to do that, he's going to do something called a pull request, which is where he pushes the files to his copy of the repo on GitHub, shall we say. And then he opens up a merge request, or if you're in GitLab, it'll be called GitLab calls it a merge request, and GitHub calls it a pull request. So he's going to open up that request, and eventually it'll merge in his changes. Now, it's worth mentioning that this point at which the merge happens, it's really complicated, and I'm oversimplifying it here. When he's ready to push the changes in, a lot of things are going to happen. So for example, Frida is going to review and merge the change to make sure she thinks it's a good change before letting that go into the main repo. Let's imagine something else happens where Annie was working on improving the frosting for the red velvet cake at the same time, and she also submitted a change to the recipe. So they have to resolve some merge conflicts that might create. And then let's also say that the merge is fine, it gets merged in, and now it's part of the main branch, but whoops, we discover that he wrote baking powder instead of baking soda. So he has to roll back those changes or something like that. So a lot of things happen. A lot of complicated things happen after that merge occurs that Ken has to be aware of. Yeah, so then let's say we have Annie, who is again working on the frosting side of these things. She wants to contribute the frosting recipes, and so she's going to be working asynchronously on her changes. When Ken pushes his changes up to the main repo, she can then pull those changes down into her repo, and then she has all the changes that Ken has made and can keep working. So there's a lot of really nice things, but that's what it means when you're pulling from upstream. It's when you're going to get the latest changes from the main repo and put them into yours. All right, so let's imagine a different scenario. What if there's a guy out there named Gerald who likes the basic cookbook, thinks it's really good, but he wants to take it in a totally new direction. He wants to make a vegan cookbook, shall we say. Well, if he wants to do that, he can fork the repo. It's a little bit like cloning, but it's where you break off a separate project from the main project. It's where it's usually intended to I'm going to go off and do my own thing with this project. So I mentioned that's kind of an edge case, but actually here in SALT, we use the fork and branch workflow in order to actually submit changes. And there's a lot of organizations that do that. So that's where you'll make a fork of the repo, make the changes on that fork, and then merge it in from your fork. So those are some of the terms that are handy to know. Let's talk a little bit about GitHub and GitLab. So GitLab and GitHub are basically 2 ways to host your repositories online. They integrate with Git. They're not the same thing as Git, but you are going to use Git if you're going to work in GitHub and GitLab. These two repository hosts are pretty similar, but each one has different strengths. There's things I like about working in GitHub. There's things I like about working in GitLab. But that's the basic idea, is that these are the hosts for your repository. And these two services add some additional features that aren't available in Git alone. For example, they make it really easy to collaborate, especially for code reviews or things like that. And they make it easy to find new projects and contribute to those projects, and to kind of see the history of what one person has done as they've committed to a project. We at SALT, as you know, we also use GitHub for our project management, so for issue tracking and things like that. If you want to dive deeper into GitHub and GitLab and how those work, I recommend reading a book by Nadia Eghbal called "The Working in Public: The Making and Maintenance of Open Source Software," and kind of how it's a really interesting study in how GitHub completely changed the culture of open source. And yeah, so I recommend checking out if you want to dive deeper into the history of GitHub and GitLab and all those kinds of things. So why am I going through Git in a docs clinic? How are you going to use Git for docs? Well, here at SALT in our SALT project, we use what's called a docs as code philosophy. That's a philosophy that you should write the documentation using the same tools and processes as code. So that means we use the same issue trackers, the same version control system that the code will use. We have plain text markup, such as Markdown, or in our case, we use restructured text. But yeah, we'll be using the same kinds of tools that developers use when they are doing their coding. Same thing with code reviews, and we use the same kind of automated tests and pipelines that you would use in code. So that's the philosophy we have here at SALT. There's several advantages to the docs as code approach. One advantage is that writers can integrate better with development teams. They're embedded in the team and working with the same kind of tools and seeing the same things that the development team is seeing. I will say, in open source, we need more writers, and so a docs as code approach is probably the best way to get more writers into open source, because there's a tremendous need for them. And I see developers all the time asking, where are the writers? Why aren't they attracted to open source? So at least using a docs as code approach ensures that some tech writers might show up to help with your project. Another advantage is that developers will often write the first draft of the documentation, which is good because they're the subject matter experts. They're the ones who really understand the tools. And contrary to popular belief, developers can write. They can do it. They're good communicators, a lot of them. So yeah, it's great to have developers contributing to the documentation because they're good at it. Another advantage is that you can block merging of new features if they don't include documentation. That's sometimes been a problem historically in open source, where docs are not included with the development work. So if you block things because they don't have docs, that's good because it incentivizes developers to handle that tech debt, to write the documentation that ensures people can use the code that they're developing. So. All right, so that's basically the high-level overview of Git and GitHub and GitLab and how it works. What I'm going to do now is do a live demo of how to do some of these things. So, that's not the window I want. All right, so I'm going to show first how to make code. A clone, my apologies, a clone of a project. You might have heard oh, my cat. Thanks, cat. You might have heard recently that GitHub itself decided to open source their docs last week. So now anybody who wants to contribute to their docs can do so. It doesn't have to be just people on their team contributing to it. So I've never done this before. I'm going to try to fork and clone the GitHub docs, and let's see what happens. Before I do that, it's always a really good idea to check out their contributing guide and to make sure that you're doing things the way that they want you to do things. If you go down here to their contributing docs, it says that they would like you to fork it, I believe. Yeah. Anyway, I saw this before, but oh, here we go. They want you to fork the repo. So we're going to do that. So in order to fork the repo, I'm going to click this fork button right here. I'm going to fork it to my name. We're doing it. Give it a second. Okay, now I have successfully created a fork of the GitHub docs. Now that I've got that in my own repository under my own name, what I'm going to do is clone it to my machine. All right, so I'm not going to use PowerShell to do that. I'm going to use my Windows subsystem for Linux, which has Git installed on it. I have a nice little Doctopus message that I like to, it's based on the Good Docs, which is another open source project I contribute to. All right, so I'm gonna navigate to the directory, and I guess this is another thing to say. You do need to be a little bit handy with the command line to use Git because it's all in the command line. GitHub has some really nice UI features to where you can do a lot in GitHub without ever having to touch the CLI. But at some point, it just gets easier to use the CLI. So keep in mind that I've already installed Git on my Windows subsystem for Linux with Ubuntu. You'll have to do the same thing. So I've already got that stuff installed. I'm going to navigate to my Git projects folder. And what I'm going to do is I'm going to use the git clone command, and I'm going to grab my clone here. I'm going to enter it in the SSH information for that. Boom, it's going to clone it, which what it's doing right now is it's pulling all of the files from my fork of the GitHub docs into my machine. It might take a moment, depending on how many things they have. Meanwhile, I'm going to go into their Git project, or into my Git projects folder. This is where I keep all of my different repos. Each of these represents a different repo. Check it out. Salt's here. The Good Docs templates are here. Anyway, so that's going to be happening. Wow, I guess they have a lot of docs. Was not anticipating that. So yeah, it's basically pulling them down. While we're doing that, I'll talk about some good resources to use for Git. If you want to learn more about Git branching, I really, really love this tutorial called Learn Git Branching. This is open source if you want to contribute to it, if you are a handy front-end developer. Basically, it'll kind of walk through and tell you about what Git commits are, how to do them, and it'll kind of give you a little visual tutorial where you have the command line, but then it'll visualize what's actually happening behind the scenes as you do those things. So, it's kind of a really cool little tool that I totally recommend. It's a good way to kind of wrap your head around how branching works, which is the hardest part about understanding Git. Just check in on nope, still going. So that's a good resource. Another resource I really like for doing what we're doing right now, which is how to fork and branch. I really love this blog entry by Scott. And if you do a Google search for using the fork and branch workflow, this kind of walks you through what you need to think about when it comes to so notice that we're on this step right now while we're making a local clone. What I'm going to do after it's done pulling down those files is I need to set up a remote. let's talk about what a remote is really fast. A remote is a reference on your Git environment for your original repo, the one that you pulled down, the one that you're doing right now. That's going to be the origin. That's set up automatically whenever Git pulls down a new clone. So it's going to automatically set up this thing that this thing as my remote for my origin. You'll see how that plays into things later. Then, since I took it from the GitHub docs, oh, this is the wrong one. Oh well, I was using, yes, okay. It's this one that it's using. Anyway, so, and then what I'm gonna need to do is set up an upstream remote that points back to the original repo, since I intend to contribute to that. Let's see if we're done. Oh, we're 90%, that's okay. Okay, so that's what I'm going to be doing next, is I'm going to set up my remote for the upstream GitHub docs. And then I will be able to create a new branch and make contributions to the GitHub. I'm not going to actually contribute to GitHub today. I just wanted to show you what it was like to do a new project. So now that I've cloned my project in, I always have to look this up because I don't do this that much. Okay, git remote add upstream, git remote add upstream. And then I'm going to make sure I'm on the right one. Get its address. So there we go. Whoop. Not a Git repository. Oh, I know what I need to do. I need to go into my actual folder. Okay, so notice on my machine now, the GitHub docs should be there. What was it called again? GitHub docs? Probably just docs. There we go. Looks like it's called docs. Okay, so I need to go into docs. Now I'm in docs, and notice that I'm on the main branch. So now I'm going to repeat that command that I meant to put in while I was here. I'm going to do git remote add upstream, and that's going to tell Git that the upstream repo is this one. So then if I want to sync up my changes with that, I will just do git pull upstream main. And what that will do is pull down the latest changes. And since I just barely cloned this repo, it's already up to date. But if some changes had been made to the GitHub docs, it would pull that down onto my local machine. And then I would push it up to my main branch on my GitHub repository. So once again, what I would normally do is in getting ready to contribute is I would do this command, the git pull upstream main, and pull those changes back down onto my local computer. Then I would, because it's only on my computer, then I would need to push it back up to my main repository. So I pulled from GitHub and then I pushed to my fork of it, which is here. So yeah, and it's called docs. So, and all of that stuff is here on my local computer under the folder docs. So that's how you start up with a new repo. And yeah, so that's that process. Now let's see what it's like to make a change using Git. So I am going to make a change to, we have a repo here in Salt called the Docs Hub, which is where we store our meeting notes for our Docs working group meetings. So you can check out those meeting notes if you want to see what we talked about last, that kind of thing. And on this repo, we have our README. And I noticed on our README that we have something that's out of date. This is out of date. We don't meet on the third Thursday of the month at 12 p.m. Mountain anymore. we meet every other week on Thursdays, and we alternate with the Docs Clinic now. So we need to change that. And we also meet at 2 p.m. Mountain Time now. So let's update that. What I'm going to do is I'm going to go into my folder where I have, so I'm going to go into Docs Hub. That's going to be confusing with GitHub naming their folder Docs, but I'll figure it out. So now notice that I'm on the master branch here. That's what our main branch is called on this one. So I'm going to first always check that you're up to date. Whew, up to date. If I wasn't, I would push it to my repo. Just a good habit to get into doing every single time you open up your repo. Now I'm going to create a new branch. The syntax for that in Git is like this. I'm going to call this update meeting time. So now notice that my branch has changed to update meeting time. I'm on this branch now. It's a brand new branch that is it's stemming off from the master branch. So now I'm going to make these changes to our meeting time. Meetings will take place every other Thursday at 2 p.m. Mountain Time, 3 p.m. Central. That Zoom is out of, rather than put in a Zoom, let's just say check the SALT community calendar for the Zoom link. There we go. And maybe later I'll put in the link to that. For now, I'm not going to worry about it. Okay, saving my file. So now I've made the changes that I want to make. Now I am going to check what, and oh, check it out. I changed the README. When I did this command get status, it told me that these are the files that I have changed. So now I'm going to add that file to my commit. Remember, a commit is saving your changes. So I'm going to git add README. By the way, if you press tab, it completes it for you, which is really handy because then you can check that you spelled it right. So git add README. Then let's check the status again. Now it's in green because it's under changes to be committed. So now it's ready to be committed. So I'm going to commit it, and then I'm going to add this flag here, -m, which is for the message I'm going to add. Now you always want to add a message that says what is the change that you made. So update the docs working group meeting time. Then I'm gonna, okay, now it's committed. Notice if I do get status again, this time nothing shows up. That's because I committed. Everything has been saved. If I were to make another change, it would show up in red like this again, and I'd have to add it again. So now I've made these changes, and it's time to push it up to my repository on GitHub. So remember, mine is the origin. So I'm going to do git push origin, and I'm going to use the branch name for this new branch that I've created. Update meeting time. Okay, what that's doing is it's creating that new branch on my upstream, on my origin repo, the one that's up on GitHub, my copy of it. And it's pushing those changes to it. So now when I go to, wrong one. Now when I go to the working, my version of the repo, now I have this notice here that says there's been a new push. Do you want to create a pull request for that? And I'm going to say, yeah, I'm going to create that pull request. So now this is a simple PR to update our docs working group meeting time. And I am going to check what those changes were. This looks right. Those look like the changes I made, which is good. Okay. And you can see here's what the old thing used to be in red. Here's the new thing in green. That looks right to me. Now I'm going to create a pull request. And if normally I would add a reviewer to this. And in fact, I'm going to go ahead and do that. I'm going to add Derek to this review.
Yeah.
Okay, Derek, I need you to check out my review, basically. So then what Derek would do, I don't know if we actually want to do it right now. We're almost out of time, so maybe don't bother. But good practice would be for Derek to review it. Like he could look in here and say, you said, let's put in the link for the community calendar. And he might maybe suggest that link there. Then I could like go back to my version and, oh, yep, I'm going to add that link here.
There you go. I just put a review and I used the suggested change feature actually in there.
Oh, okay. So let me refresh and let's see if it shows me what you said. Aha. See now, Derek wants me to add this to my review. Since he already did the commit, since he already did the suggestion, I'm just going to add it. We're just going to add it right now. So now this gets added to my pull request and it's in there now. Awesome. And then what I would usually do is I would say, hey, Derek, I merged in your changes. Can you approve this PR, please? You know, that kind of a thing. And over here, it's gonna, so notice he requested changes and I've already implemented the changes he wanted. And let me know, Derek, when you've approved it. Different repos will have,
there you go.
Look, now Derek has approved it, which means I can merge it in. Now it's merged in. Now it's up on the main branch. So check out what happens this time. Let's check out, I didn't mean to make that pun, but hey, let's check it out. I'm gonna go back to the master branch. This time I'm gonna try that command, git pull upstream master. This time there's been a little change to the README. So it pulls it down. Now this is on my local computer and I've got those changes in it. Now I just need to push it back up to my GitHub repo, my version of it. There we go. So that is how to basically use GitHub. And now you know how to contribute to the docs or to SALT as a developer. Git, of course, has a very, very, very steep learning curve. It is hard to learn at the beginning, remembering all those commands and things like that. But you start to get really used to it. So it's not too bad once you just have a lot of practice with it. And yeah, so I think that's probably going to be it for the Docs Clinic today. Thanks to everybody who came. And hopefully we'll be able to provide this to everybody as a resource for later. So, all right, thanks everybody. Take care.
Thank you, Elisa.